Okay, all these are the same properties except you're dividing instead of multiplying, and so it's going to be the exact opposite. A to the fifth over a to the third power. We can cross out all of those a's, and when we cross out all those a's, we have a squared, which you can see 5 minus 3 is going to be squared. This only works when the a does not equal 0, because if a equals 0, then we would have 0 on the bottom, and you can't ever have 0 on the bottom of a division or a fraction. Okay, and then the next key concept is right here. We've got a over b to the nth power. We can do a to the nth power and b to the nth power. So you can split it up, or you can go ahead and apply it to both the top and the bottom. And you can see how they've done that here. 4x squared over 5y to the third power. So we can say then 4 to the third power, x to the 6th power, because it's 2 times 3, over 5 to the third power, y to the third power. So when we do that, it becomes 64x to the 6th power, 125y to the third power. Similarly here, this one, we're going to do a to the 10th power over b to the 5th power times 1 over 2a squared. Now we've got a to the 10th power up here, and we've got an a squared down here. And so those two we can subtract, and so we have a to the 8th and no more a's down in the bottom. A to the 8th, and then it's going to be 2b to the 5th. Hopefully you tracked with that, but those are some great problems for you to just get familiar with what you do with exponents when you're subtracting or multiplying. And that's really your problems. These are called fraction trees and fractal trees, not fraction trees, fractal trees, and each stem goes off in 3 different directions. So the first stem is 1, second stem is 3, then we've got 9, and you can see from that it ends up being 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power. So it's basically asking how many times greater is the number of new branches added at step 5 than the number of new branches added at step 2. So at step 2, we know that the number of new branches added is 6, because it's 3 and 9. We can just subtract those. And then, but the branches added between 4 and 5, well, if 4 is 81, 5 is going to be 3 to the 5th power, which is, I don't know off the top of my head what 3 to the 5th power is. But it's 27 times the number of new branches added in step 2. I didn't read through that one, but number of new branches added at step 5 is 3 to the 5th power. Oh, I think they're doing not subtracting the 2. They're just doing all of the branches that you have. So it's step 2 would be 9, and now we're going to divide the 2 to see how many times more we're doing. So instead of figuring out what 3 to the 5th is, we can do 3 to the 5th divided by 3 squared, and then we can use our exponent division law that we learned on the first one, property that we learned on the first one, which means we're going to subtract those 2, and it ends up being 3 to the 3rd. So 27 times the new branches between the 3rd and the 5th step, 2nd and the 5th step. Okay. Hi. I hope that all makes sense, but really focus on understanding this section and understanding this section, and then with the multiplication, similarly, understanding those key concepts, that what you do, the things you can do to manipulate exponents so that your problems make sense, like that.